Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at how to do a simple structure chart associated with an older version of our P3. This particular version of our P3 focuses on our physics demo and looks at examples involving 1D, 2D motion, and beam reaction forces. Now, to begin with, we want to understand a little bit about a structure chart, and I'm not looking for specifics or very fine details in your structure chart. Essentially, what you want to do is you want to give me a visual representation of how the major components in your program interact with each other. I'm not also terribly interested in this particular example in seeing how many times they interact with each other. Basically, what we're going to do is we're going to look at our program just simply as a set of blocks and then look at the values and potentially the types of values that are being passed between these blocks. Sort of what you want to think of in the structure chart is in understanding not only the hierarchy of your program, and in other words, who calls whom or what calls what, but also then what you want to do is you want to look at how do they interface with each other. And so this is different than from a flow chart or where you are drawing the control of flow of your code, where it looks at the for loops, the while loops, the if statements. That's down too low. In this case, we're looking at it more at a block or a module level. And so what you want to do is you want to go ahead and pull up a copy of your P3 in the instructions, and you'll see that we're going to have three functions that we're going to work with. And we're also going to look at our help and see how our help interacts from a block perspective. And then we'll go ahead and draw the structure chart for this simple program. Now, the reason I say it's pretty simple is because the way this particular program works is it allows or forces all of the responsibility to presenting the results to the functions themselves. In other words, each one of these functions, projectile 1D version 2, 2D version 2, and beam version 2, all of them accept input arguments, but they don't actually return anything other than exit success or failure. And so there's not any calls, or excuse me, there's not any way for the main or the calling function to actually see what the results of those calculations look like. We're going to just simply print them to the console. So this is going to be fairly simple structure chart. They can get much more sophisticated than that. But let's go ahead and get started with this particular one. The tool we're going to use is a tool that formerly was known as draw.io, but is now known as app.diagrams.net. It's an online tool for doing a number of great things, including flow charts and structure charts. It's just a great tool to get familiar with. And so go ahead and create a new diagram. We'll go ahead and call this one P3. P3 underscore structure underscore chart. And as far as I'm concerned, you can go ahead and just leave it with a blank diagram. Now, I'd encourage you to play around with this because, as I said before, this is a very, very nice tool. And then we're just going to go ahead and create. It's going to ask you for a location. And what I'm going to do is I'm simply going to go find my P3 project that I have already completed. And I'm simply going to use the exact same folder. And go ahead and say this as our P3 structure chart. Now, we said that there were only a few components in this particular example. I'm not going to worry too much about the aesthetics here. I'm going to leave that up to you. I'm just going to show you how you're going to lay them out. We're going to start by putting our main up top here. You can arguably go ahead and include then the arguments themselves. Probably wouldn't be a bad idea. So we're going to have our argc and our argv. I am not going to bother with the types associated with them. You're more than welcome to, but this just gives you a reference for this main structure or this main block in your code. The next one that we want to go ahead and include is going to be our projectile underscore 1D underscore V2. And the only thing it accepts then is going to be our Y init. And once again, for this example, I'm going to de-emphasize the values, or the data types of the values rather. And we're going to go ahead and add another block here. This is going to be our projectile 2D, and this is going to be V2, and it required two pieces of information, the V init and the theta. And once again, I'm going to have a little bit of fun with this. I'm going to try to make it look consistent here. So I'll tell you what, I'm going to go ahead and line them up first so I can get the same size for all of them. I think you can quickly guess this is one of those opportunities that you can spend a lot of time with this. So simple supported beam. And for the simple supported beam, you were required to provide a W, an L, and an A, which represents the location. At this point, then let's go ahead and stretch all of these out just to keep them the same size. Once again, this part you could argue is completely unnecessary. I just want it to look reasonably decent. And then the other one that we also want to include here is going to be our help. And once again, there's no real magic as far as where you put these. Once again, you can be as creative as you want to with this, as long as it conveys the message. And then what we're going to do now is we're going to draw arrows from each one of these functions or blocks to show how they interact with each other. And so, for instance, if you think back to how you programmed your P3, none of these functions called your help necessarily. Who was responsible for calling your help? Well, in this case, the only thing that actually could call your help, oops, did not mean to accidentally delete that. I'll hit Control Z. Let's do that one more time. The only thing that was responsible for calling your help was your main. And tell you what, why don't we go ahead and move this over here to the side so that it doesn't get too cluttered. And then more specifically, then it passed no arguments. So in other words, there were nothing passed to it. And likewise, nothing passed from it. Now, in the case of your other functions, and we'll just go through them one at a time here. Our projectile 1D, we passed to it a Y init or an initial Y, and then we returned from it success or failure. And in all of these functions, if you recall, and we're going to slide this one down a little bit just so that we have enough room. They all returned either success or failure. And so in other words, I'm just going to go ahead and do a little creative copying and pasting here. And then what we have here then for the projectile 2D is going to be the V init and the theta. And then for the simple supported beam is going to be the W, the L, and the A. Now, the only other thing that I would suggest doing for this is go through and on the arrows, then what you can do is you can specify the type of arrow for the other end. And so you take a look, we have the starting arrow, and then we can also specify the ending arrow and just do that for all of these. Matter of fact, probably wouldn't have been a bad idea to go ahead and set that up as the default when we were doing this. But there you go. Now that indicates that there's some sort of bidirectional communication between each one of the major blocks in your program or in your system. As you can see, you can spend a lot of time making this look even better. But functionally, this shows us what the structure of our program is. At this point, you want to go ahead and save your draw.io, or rather your app.diagrams.net file. And then you also can go through and you can do an export as and export it as a JPEG or as a PDF. So just for a little bit of variety, we'll go ahead and export this PDF. Excuse me, as a JPEG, it goes ahead and specifies the .jpeg file extension, download it, and then you have a nice little diagram that you can include in any sort of documentation about your code. So as always, hopefully you found this video useful. If you've got any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.